Hi guys, welcome back. I'm Amit Tawar from Networkers Home Technical Team, and today's topic is SSL Handshake process. So in the previous video, we have discussed about SSL, what is SSL, why do we need SSL, and about SSL history. And we have discussed about SSL different scenarios like handshake, because in the SSL handshake itself, there is a three scenarios. The scenario one is SSL server-based authentication. The second is client-based authentication, and the third is your session resumption there. So these three different type of handshake processes are there, and different scenarios are there. And out of these three, so this is the first one. So in this video, we'll discuss about server-based authentication handshake process. So let's start. So server-based authentication. So as per server-based authentication, so let's consider this is client and this is server. So first of all, the SSL handshake process will be initiated by the clients itself there. So first of all, client will generate the first packet, and the first packet name is client hello here. So this is client hello and will send to the server side. Then server will reply as a server hello, then about certificates as a third message. Then in the fourth message, it will reply as a server key exchange, and the fifth message is all about server hello done here. So the first message will be initiated by the clients, and after that, and a reply, the server will send the four different messages there. Okay, so the first is server hello, then certificate, server key exchange, and server hello done here. So these are the five messages. First of all will be exchange. After that, the sixth message will be initiated by the client, and that is client key exchange. The seventh is change cipher specific. Eighth is about finished. So these are the three packets now initiated by the clients. And then on the another side, server will initiate again, change cipher specific, and then finished there. So these are the 10 messages which will be exchanged between client and the servers. Okay, so we'll discuss about these messages now in depth. So let's start it. So this is client. This is all about client here. And this is about server. Okay, the server address is like server.com. So you have to use here HTTPS, and then you have to type here server.com here. So the first of all, then there will be DNS, and after that TCP three-way handshake process, and then there will be SSL here. So about these three things we have discussed in the previous video. So here directly we will go to the SSL handshake. So just now we have seen in SSL handshake. So the first message will be initiated by the client. So this is message one, and this message name is client hello. What are the things this client hello will contains that we have to discuss now? So let's start. The first thing in the client hello. So guys, in the client hello, the first thing is about SSL version. What are the things? And in the SSL version. So SSL version, what are the things there? Okay, how many things are there? Like what are the which version of SSL actually are you using? Are you using SSL version v3, or are you using TLS 1.1, 1.2, or 1.3 here? So this will be the information which will be mentioned in the client hello and the SSL version field. The second is session ID. Session ID, it can be the two values there. There will be some, it can be 0, and it can we have some values there like 1, 2, 3, 4, 5, A, B, C, 1, 2, 3. This is ID. There's a two possibilities. Maybe this one or maybe this one here. So what are the possibilities? What are the scenarios here? The scenarios are the session ID will be 0. It will be 0, or you can say null. If client is trying to initiate new connection. Okay, then it will be null. So then if client is trying to initiate the new connection, and it can have some value, and that scenario is if client is now trying to resume previous connection. So this is the third category of the SSL handshake process. Okay, I told you in the starting, in the server-based authentication, then client-based authentication, client and server-based authentication. The third is about connection resumption there. So that will be in the next to next session there. Okay, so right now this is this package. So in this video, we are discussing about here new connection there. So this time the session value will be 0. So it means the client is trying to establish the new connection with the server there. Okay, so this is about session ID. So session ID will define, is it, or with the help of the session ID, server will get to know, is this client trying to resume the previous session or trying to initiate or trying to establish the new connection there. So this is all about session ID. Next is Cipher Suit here. Cipher Suit. What is the Cipher Suit? Cipher Suit is a collection of the algorithms which we are going to be used for encryption, decryption, for hashing, and for the key exchange and the method of authentication also. So these are the things. Okay. So what are the syntax? Now, the syntax of ciphertext. Okay, Cipher Suit, sorry. So as per syntax, so first of all, this is the syntax. TLS, this is about Diffie-Hellman, elliptic, DSA, this is about authentication with AES 128. This is all about encryption, and then SHA-256, all about integrity. Now, so this is all about the version of the protocol. This is all about version of protocol. Which version of protocol are you going to be using? Then the second is, this is all about elliptic curve Diffie-Hellman. It's about elliptic curve Diffie-Hellman. Okay, so this is all about key exchange concept. Then this is about elliptic curve digital signature. So this is all about authentication. For authentication, we are going to be use here certificates. The next is about encryption. So this is all about encryption here. Okay, so this is AES with Galois counter. Okay, and finally, in the last, this is all about their integrity. Okay, so this is about Mac. Message authentication code. Okay, so this is the syntax of the Cipher Suit here. So client will send more than one Cipher Suit. Okay, this is Cipher Suit A with the different variations, then B, then C, then D, then E. Like this is about AES encryption with MD5. This is about different variation than 3 dash with MD5. Okay, then this is about AES with SHA. Okay, then this is about dash with SHA. Okay, and this is again AES with SHA 2. This is about 256. Okay, this is about 5125. So different variations. Okay, and these are the inbuilt or predefined cipher suits in all the browsers like Google Chrome, Firefox, Internet Explorer, and all. Okay, so they will send like kind of proposal. Client will send this proposal to the server. Ki, hey server, I just can support all these cipher suits here. So please select any one, and then we will start the communication as per that cipher suits there. So then server will select the one out of these. Maybe client can send maybe 10, 12, 15, 20, depends. Okay, so as per out of that list, then server will select the any one and then reply with that selected cipher suit there. So this is the third thing. Next is, still we are talking about client message only, client hello, when we are sending the information here. The second is random number. Random number contains two things. Okay, its size is 32 bytes. It's divided into two parts. One is 28 bytes and second is 4 bytes. So this is all about timestamp. Okay, so it will contain about time, okay, and about zone, time, zone, and as well everything, and 28 bytes. So this is all about one random number. Okay, it could be 1 2 3 4 5 6 0 7 8, like size will be 28 bytes. So the question is, why do we need the random number? That we will discuss during the packet number 5th and 6th later on. Okay. Now, after the random number, next concept is compression method. About compression method. Now, what is a compression method? Compression method means, actually these days the compression method will be null. Okay, and this one. So what does that mean? Compression method will be like if you have 10 GB of the file there, so you can compress into 3 to 4 GB. So by default, so if you want to enable it, okay, compression method we want to use it, so then you can, otherwise it can be null. So this is the compression method which will compress your data. Next is extensions. Extension is what? This is kind of extra information. This is kind of extra information there. So there, okay. So like okay, extra information. So the first is about SNI. Most of time, this is one of the important you can say extension is there. So which will be sent by the client towards the server there. So server SNI means it's all about server name, server name, one second. The SNI means server name identification here. Okay, so this is all about server name identification over there. So like this way, and identification. So let's consider you are trying to access any Amazon in the actual network, so Amazon.com. So then what will be there here in the SNI? What will be mentioned? Amazon.com. Means you are trying to access which server? You are trying to access over the Amazon over there. As per our example, what we are using right now, then there will be server.com. Okay, so there is a different extensions out there. So this is kind of some extra information which will be required during the further communication. Okay, so if I'm talking about extensions there, there's a almost 8 to 12 different extensions out there. The first is about SNI, server name. The second is status request. Next is signature algorithm. Next is heartbeat. Okay. Next is application layer, protocol negotiation. Okay, then signed certificate timestamp. Okay, then padding. Okay, after that session ticket. Then next protocol negotiation. Protocol negotiation. And after that, renegotiation information. Renegotiation information. So these are the different extensions. Okay. After that, during the packet capture in the starting, we will discuss about only, or I'll show you SNI in the next video. That will be about all about the packet capture step. About all these extensions, we will discuss in the further videos. There will be one specific video that is all about extensions only, and that time we will discuss about it. So these are the information. So overall, if we are sending, when we are sending client hello, so what all the informations it will send it? It will send the informations like, I'm just trying to recall the things now. SSL version, second is random number, then session ID, then Cipher Suit, then compression method, okay, and after that extensions. So these are the things. Okay, then second packet will be now server hello. Okay, so server hello, the first information is all about in the server hello, the first information is all about SSL version. Then server will reply with the same SSL version which was requested by the client. Then random number. This is server random number. This is not the previously, that was the client, and this is our random number. Again divided into two parts. One is a random number of 28 bytes, and second is time stamp. The third thing is session ID. So last time the session ID from the client hello, if I'm talking about in the client hello, that was null. But this time session now server will generate the session ID, whatever will be the session ID, and that will be mentioned into the this list. Okay, and the session ID size will be 32 bytes. will be the 32 bytes. Now, this is about session ID. After that, selected Cipher Suit. So previously, client has sent more than one Cipher Suits there. So server will select one Cipher Suit from that, and then it will reply to the client there. Okay, whatever will be there. After that, same compression method, and then extensions. Okay, so same, these are the informations which will be sent by the client, which will be sent by the server in server hello messages. Okay, so this is that information. So this is all about server hello. The next message is now, next message is all about your server hello, and now it's all about certificate. It's all about certificates here. So next is certificate. So server will send the certificate to the client side. Certificate. Now let's consider this is server, this is that server, and this server is using the server of, maybe there is a possibility, maybe they are using the servers of the certificates of GoDaddy, because this is the one of the organizations, okay, and this is one of the CA authority, certificate authorities, okay, in the corporate, okay, okay, and they release the certificates to the different servers. And for that thing, who is hosting the server, those guys has to pay to the GoDaddy and that particular organization. So this is all about DGCRT as well. So these are the two ones I have mentioned here, but it's in a long list actually. So there is a lot of different certificate authorities out there. So let's consider server. The server is using the certificate, and this is the certificate which will be downloaded or issued by GoDaddy here. Okay, so now, so this certificate now will be sent to the client side, and this is for authentication. This is for server authentication. Now server is trying to authenticate himself ki I'm the authorized person, ki now you are trying to access me and I'm the what, I'm the authorized person, and what is the proof for that? The certificate is the proof for that, and that will be sent to the client. Then client will be verified with the help of the expiry date. So then client will rectify the is this the authorized person or not. So then in the server side, on the client side, okay, this certificate will be encrypted. It will be encrypted by GoDaddy private keys. Private key. So once this certificate will reach to the destination side, now in the browsers, in the Google Chrome and all, so we have root certificates, and these are the kind of public keys of GoDaddy and DGCRT kind of C authority. So with the help of those keys, will de-encrypt the packet and then we'll check it what is the expiry date of the certificate. Okay, if certificate is already expired, so then client will reject it and will say no, you are not the authorized person because your certificate is already got expired. So client will make sure the certificate should not be expired there. Okay, so client will verify. After that, server will send again server key exchange. So now what will be happen? Next packet is about server key exchange. So this time server will send its public key. What will send? What the server will send? Server will send its, this is all about server public key. Okay, consider 2, 3, A, B, C like that. So what is the use of the public key? We'll discuss. Then next packet is again, this is server hello, done. This is server, hello, done. Okay, so these are the messages over here. Okay, so now server will send the here different messages. Okay, so after once a client hello will be received on the server side, then server will send it first of all. Server will send first server hello. It will send first of all the server hello, then server hello will contains all this kind of informations. Then it will send certificates there. So this is server certificate here. Then server key exchange is all about the public key of the server. Okay. And after that, we'll send server hello done. Okay. Now it's time for client. Okay. So now on the both the sides case, what are the things we have exchanged? On the server side, okay, there is client random number. There is now server random number. Okay. On this side, there is client random number. Okay. And then there is server random number. On this side, we have server public key as well. So these are the main things which we have exchanged. Okay. So now what happened? What client will do? Okay. So from here, okay, client will generate pre-master key. Will generate pre-master key. Okay. Now, then how will it generate? Okay. Client will use the 3 to 4 things. They will use first is the selected Cipher Suit plus public key of server. Public key of server. Okay. So let's consider right now. So they have now client has generated the pre-master key. And for example, this is the pre-master key now. This is what? This is pre-master key here. And this is the key. 1, 2, 3, A, B, C, 3. Now, this pre-master key will be now, this pre-master key will be encrypted again with the help of now will be encrypted with server public key, not with the client. This is server public key. And then after that, client will send this pre-master key to the server. So this concept is known as here client key exchange. Client key exchange. So this is the pre-master key now on the server side. Okay, this is that encrypted key. 1, 2, 3, A, B, C, 2, 3, and that is already encrypted. So the question is, how server will check this public key? So then server will decrypt this key with its private key, or you can say server private. Okay, so now on the both the sides, we have now here pre-master key, that is 123 ABC 123 generated by client, and then we have pre-master key 123 ABC 123, which is decrypted, which is now decrypted over here. Okay, so this is what common pre-master key, common pre-master key. Now both the server and clients, okay, server and client will generate master key. Server and client will generate master key. How? They will use pre-master key, and plus on the both the sides, what we have already, or we have already exchanged server random number and client random. So this is again server random number and client random number. We'll use these random numbers and then we'll generate master key. Now consider this is the master key here, and this is the master key. Okay, so they will use here one PFS function, and with the help of that PFS, they will generate whether your master keys over there. Okay, so now on the both the sides, there will be the master key that is considered 1, 2, 3, 4, 5, 6, ABC, 1, 2, 3, 4, 5, 6, then ABC here. Okay, then after that, on the both the sides, both the server and client, with the help of the PFS again, they will generate 3 more keys there. Okay, so first key will generate for integrity, next key for the encryption, and third key for the initialization vector. So this is again for integrity, then about encryption, and then initialization vector. Got it? Now what happened? So now we have already exchanged, and on the both the sides we have integrity key. Now we have key encryption and for IV and for this one. So now what happened? Next, client will send next message here. That is change cipher specific. Okay, and in this message, it will send this kind of first encrypted message, or you can say kind of demo. Okay, and finally we'll send it finished. Okay, now let's start with encrypted data exchange, because now we have keys on the both ends there. Okay, and we have generated it from the same master key. It's also the same. So I'll encrypt the fake data with this encryption key, and I'll hash the data with this integrity key. And now you have also the same key on the another end, so you can decrypt, and then again you can do the hashing. So this is from client side. Finally, then server will send again what? Change cipher specific. Okay, and will send first encrypted message, and this is finally now finished. Yes, we are done. Okay, this change cipher specific means it means as like pending state to current state. What does it mean? Okay, before that, the data was not encrypted, and now we shifted to the encrypted one here. And from this packet onwards, all the communication will be hashed and then encrypted. So this is SSL handshake. So the first is client hello, which will send, first of all, we'll send the SSL version. Then in that session ID, Cipher Suit, compression method, extensions, and random number. Then same from the server side again, it will send the selected SSL version, then about random number, then session ID, because session will generate the session ID this time. Client will send session ID as a null, and it will generate the session ID and then will send the same session ID with the server hello. And then server will send the selected Cipher Suit with the help of the certificate. So with the help of the certificate now, server will try to authenticate himself. Okay, so this concept, this process, whatever we are discussing here, so this is all about server-based authentication. So there is no authentication happening, or there is no certificate exchange from the client side. Then server key exchange. This is about the public server key. Then server hello turn. Then on the another end, client will generate first pre-master key with the help of Cipher Suit and public key, and that pre-master key will be shared with server, and that key will be encrypted by server public key only. So if key is encrypted by only server public key, so who can decrypt that particular packet? Only server can decrypt that particular packet with the help of its private key. So then it will restore the destination. Now pre-master key will be reached to the server. Server will decrypt that packet with the help of its private key, and then will get the pre-master key there. After that, both the sides, they will use PFS function, pseudo function there, and with the help of the pseudo function, will generate master key with the help of random numbers. And then from the random number again, from the master key, again will generate the three keys then. One is integrity, then one second for encryption, and third for the initialization vector. And after that, they will start, or they will go with a chain cipher specific, and here onwards, all packets will be encrypted. So then finish from the client, and then from the server side, chain cipher specific, and then finished. So this is all about server authentication. So SSL handshake scenario as per server-based authentication, because in this handshake, only server is trying to authenticate, or server authentication is happening. That's it. Okay, guys. Thank you for watching the videos.